In Chapter 5, we will investigate how to see if an observed effect is significant or not. To that end, we will define hypothesis tests. So far, we looked at the sample, we did a descriptive statistics, we looked at the effect of captopril in the sample, and we made estimates. We made estimates, a range of plausible values for the population effect of captopril. However, such a range of plausible values is not an answer to our research question. For the research question, we want to say if the effect is significant or not. So we want to give a yes or a no answer and not a range of plausible values. To do that, we will apply a statistical test. For captopril, for example, we would like to know if it has an effect on the systolic blood pressure. For this, we do not just want to have a range of plausible values, a range of likely values of the effect, but we want also to be able to say to our client, yes, it has an effect, or no, it does not have an effect. It is not always trivial to make such a decision based on the data. Our data contain a certain level of uncertainty, and our conclusions will therefore also be uncertain. So the question then becomes, if we see an effect in the data, is this effect found by chance, so just due to randomness, or is it a systematic effect, a real effect in the population? To answer that question, statistical tests were developed. Globally, each statistical test will follow the same steps. The details will differ, but the global outline of a statistical test is the same. So first we have to define a hypothesis. Secondly, we will define a test statistic. So a test statistic is just a value that we can get from the data and that we can use to quantify the effect to see if the effect is likely or not. And then we have to define a decision rule.